In this video, we are going to look at section 3.4 quadratic models, and I will be doing problems 4 and 8 on page 154. Okay, so problem number 4 asks about determining revenue. So they give you that the price in dollars of the quantity X sold of a certain product obeys the demand equation P equals negative 1/3 X plus 100. Okay, and X represents the quantity sold. Okay, so X represents your quantity sold. So they say, find a model that expresses the revenue as a function of X. Okay, revenue as a function of X is equal to revenue. How much you sold times how much the price was. Revenue is the quantity sold, X, times the price. And that's true for anything in real life. How much money you bring in is how much you sold times how much the price was. That's not your profit. Be aware that revenue is not your profit. Your profit is your revenue minus your costs. So this is just how much ends up, in the cash register, so to speak. But it's not how much you're taking home with you. So this is going to end up being X times the price, which is negative 1/3 X plus 100. Okay, so there is your revenue. Okay, as a function of quantity sold times the price. All right, so now ask for the domain. So this is a parabola, hence quadratic models. This was part A. Okay, so the domain, I'm just going to write this out as negative 1/3 X squared plus 100 X. Okay, so your domain are going to be your x-intercepts. The domain are going to be your x-intercepts. So actually, I'm going to go back to the factored form. So I'm going to have x equals 0 using the factored form, and negative 1/3 X plus 100 equals 0. Well, of course, X equals 0 is an intercept, right? You don't sell anything, you have no revenue. And then solve here, and you would end up with 300. So your domain is 0 is less than or equal to X is less than or equal to 300. Okay. The next part, part C, says, what is the revenue if 100 units are sold? Okay, so this is just a plug-in. The revenue when 100 units are sold. So that's going to be equal to negative 1/3 times 100 squared plus 100 times 100. I plugged in right here. So 100 squared, 100 times 100. And when you are all done, I believe this equals $6,666.67. So essentially, $6,667. I always get asked, how do I round with money? You round properly. You always round to the nearest hundredth. Always round to the nearest hundredth. So part D says what quantity maximizes revenue? What's the maximum revenue? And that, my friends, is the vertex. If you want to know what quantity maximizes revenue and what is that maximum revenue, that is your vertex. So I'm going to go back. I'm just going to rewrite it. Negative 1/3 x squared plus 100x. Opposite of b over 2a, which I believe is 150. So that's your maximum quantity. And in order to achieve that maximum quantity, what is that revenue? So plug back in. So the R of 150, it's a negative 1/3, 150 squared plus 100 times 150, and that would be $7,500. So selling 150 of this item, whatever it is, will give you a maximum revenue of $7,500. That's only part of the story. How much do I need to charge in order to get 150? How much do I need to charge in order to get that sale of 150 maximum quantity? And that you're going to plug into the price. So the price is equal to negative 1/3 times 150 plus 100, which is $50. If I charge a price of $50, I will sell a maximum quantity of 150 items, which will bring in a maximum revenue of $7,500. You're going to learn a lot about this in econ, but how do you know what price you should sell them at in order to maximize your quantity? There's lots and lots of data and statistics and all kinds of stuff that's, if you decide that you want to be a business major, that will help you out with all of that. All right, that is number 4. This is number 8. For as long as I have been teaching this course, there have been problems regarding enclosing a rectangular field. Always, so get used to this type of problem. Number 8 says, Beth has 3,000 feet of fencing available to enclose a rectangular field. Okay. There's my rectangular field. Express the area of the rectangle as a function of x, where x is the length of the rectangle. Okay, so x is the length of the rectangle. Maybe it doesn't matter. Maybe you want to put your x here. Who cares? All right, so here's the deal. I have 3,000 feet of fencing. I have 3,000 feet available. I've used up x here, and I've used up x here. So after you take out the two lengths, 3,000 minus 2x remains after you fence in these two lengths. Okay, but it's a rectangle, so these two sides need to be the same. These two sides need to be the same. So for the width, it's 3,000 minus 2x over 2. Which last I checked was 1500 over x. Sorry, not 1500 over x, 1500 minus x. I misspoke. When you add up these 4 sides, I believe we do get 3000. So it says express the area. So area is length times width. So x times 1500 minus x. You can leave it that way, it's totally fine. For what value of x is the area largest? You can plug into your calculator if you want, but you don't need to. This is an upside down parabola. You're looking for the vertex. This is the same thing as negative x squared plus 1500x. Negative, upside down, boom. If you want to maximize the area, you want that vertex. So I'm just going to do opposite of b over 2a. I think this is part B. Yeah. So opposite of b over 2a, which I believe is 750. And we're talking about feet. So x is the length of the rectangle. The area is largest when this length right here is 750. And what is the maximum area? Plug in. So the maximum area is the A of 750. So that is negative 750 squared plus 1500 times 750. I can plug in right here. That's totally fine. I plugged in there, makes no difference. When you're all done, you should get 562,500 square feet. And there are the beginning of some quadratic word problems.